Thanks for joining me today. In this video, we are going to continue our discussion of solutions, specifically concentration and how to calculate concentrations. So let's remind you about what concentration is. Concentration, by definition, is a measure of the amount of solute that is dissolved in a given amount of solvent at a certain temperature. Now, there are many different methods for measuring concentration. They have different forms, different ways of doing it, different names. We have something called percent by mass, so it's what percent of the total solution is your solute. We have percent by volume, same thing, what percent of the volume of your solution is the solute. We have molarity, which is a little bit complicated. We have mole fraction. Those four are great, but for our purposes, the only one we actually care about is molarity. Now you'll notice that these last three, molality, mole fraction, and molarity, all have MOL, mole. So they are going to all deal with moles. But of course, we only really care about molarity, so let's talk just about molarity. But it does, of course, deal with moles. So molarity, by definition, is a measure of the number of moles of solute dissolved per liter of total solution. So that's very important. It is specifically the moles of your solute dissolved in it per liter of solution. So molarity is symbolized in our equations with a capital M. The unit for molarity is either going to be moles per liter or a capital M again. Now that capital M, when it is used as a unit, is read as molar. So I would say I have a concentration of 12 moles per liter, or I could say I have a concentration of 12 molar. So a 12 molar solution is a solution that has a concentration of 12 moles per liter of solution. That is the basic definition of molarity. And so the equation for molarity is exactly what it was probably, you could probably figure it out quite easily by just looking at the definition. It is, molarity is equal to the moles of dissolved solute per liters of total solution, per meaning divide. So our equation is molarity equals moles per liter, moles divided by liters. So that's how we're going to solve problems dealing with concentration. So let's look at some example problems. So our first example problem here, what is the molarity of a solution containing 2.3 moles of sodium chloride in 0.45 liters of water? So I have my molarity is what I am looking for. What is the molarity of a solution containing? My moles is 2.3 moles in 0.45 liters of water. So my volume is 0.45 liters. All right, so if my equation, molarity is moles divided by liters, then obviously I just plug into my equation. So my molarity is going to be equal to 2.3 moles divided by 0.45 liters. Moles divided by liters is molarity. So when I do that division, I get an answer of my molarity is 5.1111 repeating, but obviously I need to round to proper significant figures just like always. So if I have two significant figures here and two significant figures here, my answer needs to be rounded to two significant figures. So my molarity is 5.1 molar. So you'll notice that a capital M is the symbol in the equation. It is also the unit. So molarity is 5.1 molar. Now you could also write 5.1 moles per liter, and that would be a correct unit as well. So let's do another example. So what is the molarity of a solution that contains 120.56 grams of calcium nitrite dissolved in 240 milliliters of water. Now, I'm going to have to do a couple of conversions here because you'll notice that this is 120.56 grams of calcium, not sodium, of calcium nitrite. Well, the problem is this is grams, but my molarity calculation specifically requires that I use moles. So I'm going to have to convert this to moles before I do anything else. So the molar mass of this compound is 132.088 grams of calcium nitrite. Now, hopefully you still remember how to find the molar mass of a compound and how to convert to moles, because this is going to equal 1 mole of calcium nitrite. So I am then going to, my grams cancel, and I'm left with moles, so I'm converting it to moles. So I do 120.56 divided by 132.088, and when I get that, that gives me my moles of 0.91272 moles, rounded to 5 significant figures because that's what I started with. So I have 5 significant figures. So this is now my moles. So to find my molarity, all right, my molarity is moles per liter. Well, I have my moles, that's 0.91272 moles, divided by liters. Well, the problem says 240 milliliters. So I have 240 milliliters. That's off the screen. Let me bring that back. I have 240 milliliters, but I need that to be liters because it has to be moles divided by liters. So 240 milliliters, well, my decimals right here, milli, I'm going to move to liters. I have to move the decimal 1, 2, 3 places to the left. So that gives me 0.24 liters. So I have 0.24 liters. So my moles divided by my liters, I now put this into my calculator, and I get an answer of my molarity equals 3.8 molar when you round it to the 2 sig figs that we need, because there's only 2 sig figs in this problem. And my original 240 milliliters only had 2 sig figs. So there we go. If I give you the mass, you have to convert it to moles. If I give you a volume in something other than liters, it has to be converted to liters because your units have to be moles divided by liters. That's what makes it molarity. That is the definition of molarity. So what volume of water should be used to dissolve 19.6 grams of lithium fluoride to create a 0.32 molar solution? So what volume of water? So this time I want to know the volume, and I gave you the mass in grams of 19.6 grams of lithium fluoride. So I know I'm going to have to convert that to moles. So I have 19.6 grams of lithium fluoride, and the molar mass of lithium fluoride is 25.939 grams of lithium fluoride in 1 mole of lithium fluoride. So I convert that to grams, and that gives me 0.756 moles of my lithium chloride. And I want to have a molarity of 0.32 molar. Okay, so this time I have my molarity equals moles per liter, and I want to find liters. So to do that, we could go through all the algebra rigmarole, but this is really easy. When you have 3 variables like this, all I'm going to do is have these 2 switch places. So that means my liters is going to equal moles per molarity. So now if I plug in my numbers, I have 0.756 moles divided by 0.32 moles per liter. That's my molarity. The moles cancel out, I'm left with liters. So that gives me my unit. So now let's look at the number. 0.756 divided by 0.32 gives me a final volume of 2.3625. But I look back at the numbers for my problem. I had 3 significant figures and 2 significant figures. So my answer needs to have only 2 significant figures. So I'm going to round this to a final answer of 2.4 liters. Again, it's volume, and volume in a molarity question is always going to be in liters. Now, how many grams of potassium phosphate are needed to make 3.79 liters of a 3.90 molar solution of potassium phosphate? Well, first off, I want to know how many grams I'm going to need. So that means I'm going to have to find the number of moles first so that I can then do a mole conversion. So it gives me the molarity of 3.90 molar and gives me a volume of 3.79 liters. So if my molarity is equal to moles per liter, then to find moles, I simply multiply both sides by liters to get that to cancel out. And so my moles are going to equal my molarity times liters, which in this case is 3.90 times 3.79. So I multiply those together and I get that my moles are 14.781 moles of my compound of potassium phosphate. Excuse me. Now, this 14.781, I need to round it to 3 significant figures, so that's going to give me 14.8 moles. Well, I want grams, so now I have to convert my moles to grams. So if I have 14.8 moles of potassium phosphate, I am then going to have 1 mole of potassium phosphate is equal to 212.264 grams of potassium phosphate. And then my moles will cancel. I'm left with grams. So now I'm simply going to do 14.8 times 212, and that's going to give me an answer of, forgive me, I'm going to erase this. That's going to give me an answer of 3,141.5072. But again, I need proper significant figures of 3. So 1, 2, 3. So my final answer is 3,140 grams of potassium phosphate. And there we go. So if I ask you for grams, you know you're going to have to find moles first. If I ask you for liters, you're going to have to use the equation. If I give it to you in milliliters, you're going to have to convert to liters. So there are going to be a little bit of conversions involved with this. Other than that, it's just plugging into a 3-variable equation. So it's not super mathematically complicated once you get past the conversion aspect. But that's how we calculate molarity. Now, dilution is the process of changing the concentration. Remember, concentration is how much solute is dissolved. Well, if you want to decrease the concentration, so I have something that's really highly concentrated, and I need to decrease the concentration. Well, there's 2 ways to decrease the concentration. If your molarity is moles divided by liters, to decrease the concentration, you can either decrease the moles or increase the concentration. So if I have the moles equals, or molarity equals moles divided by liters, if I want this fraction to go down, I want to decrease it, I can either decrease the numerator, which would make a smaller number on top divided by a big number, which makes the whole answer smaller, or I can increase the denominator, which makes a number on top divided by a bigger number, which makes the answer smaller. So I can either decrease the number of moles dissolved, or I can increase the volume of the solution. Now it's really hard to take moles out of solution. Once it's dissolved, it's really difficult to get them out if all I want to do is dilute it. I want it to be a less concentrated solution. So I can easily decrease the amount of solute. I can't do that easily, but what I can do is change the amount of solvent. I can increase the amount of solvent, so I can add water to my solution, and that will decrease the concentration. It dilutes the solution. So to dilute a solution, you add more solvent. That's the best way to do it, is to just always add more solvent. Now, since molarity is that ratio of solute to solvent, we can say that molarity and volume of a solution are inversely proportional to each other. So that molarity that we just saw, and we have a equation, they're inversely proportional to each other, because if I put my liters and my molarity on the same side of the equation, they're multiplied together, just like Boyle's law, which was an inverse relationship. So increasing the volume of the solution is going to decrease the concentration. They're inversely related. And that gives us an equation of M1V1 equals M2V2, where M is my molarity and V is my volume. So the molarity times the volume before has to equal the molarity times the volume after. Because what that is, the molarity times the volume, is the number of moles of solute. So we're not changing anything about our solute, we're just changing the concentration by changing the volume. So our number of moles has to stay the same. So our moles times volume, or molarity times volume, before we change something has to equal the molarity times volume after, so that the total amount of moles of solute remains the same. And so this is our equation. M1V1 equals M2V2. It's very much like Boyle's law. It's a very simple equation. And so let's look at how we would do that. So to dilute a concentrated solution, you measure out a volume of the concentrated solution, and then you add water, or whatever else your solvent is, usually going to be water. You add your solvent to attain the desired concentration. So if I have a highly concentrated thing of acid and I need to dilute it to a very specific concentration, I do my calculations to figure out how much my concentrated acid I need to start with. I would add that small amount of concentrated acid to a container and say I need 100 milliliters, and I add 10 milliliters of my concentrated acid. That means I need to pour in water to bring it up to the volume of my overall solution, which will give me the concentration that I need. All right, so let's look at an example of just that. I want to dilute some hydrochloric acid. Hydrochloric acid comes from the manufacturer in bottles of 12.0 molar concentration. So my concentrated molarity is 12.0 molar. Now, for an experiment, I need 100 milliliters, so I need a volume of 100.0 milliliters, and I need it to have a concentration of 1.00 molar. So I need 100 milliliters of 1 molar hydrochloric acid. What volume of my concentrated solution am I going to need? So notice I called this M1, so I had to pay attention to the words to figure out whether this volume went with this concentration or which volume and which concentration goes together. Okay, so if I know that M1V1 equals M2V2, then all I'm going to do to find my V1 here is divide by M1 on both sides so that they cancel out. So my V1 my volume that I'm looking for, the volume of my concentrated amount, is going to be the multiplication of that divided by that molarity. So I'm going to have 100.0 milliliters times 1.00 molar, so V2 and M2, divided by 12.0 molar. And when I do that, I basically multiply that out. You'll notice that the molarities unit cancels out. I'm left with milliliters. That's the cool thing about this is even though volume for molarity has to be in liters, the volume of my solution does not. It's just whatever my volume here, that's what I'm going to end up with my unit. So I have V1 is going to be 8.33 milliliters. Now it's milliliters because I had milliliters here. That's how much of our concentrated solution we're going to need, which actually leads us to the rest of this question. How much water do I need to add to the concentrated hydrochloric acid? So the way I'm going to actually dilute this solution is I'm going to measure out 8.33 milliliters of my concentrated solution. So I measure out 8.33 milliliters of my concentrated solution, and I'm going to add some amount of water to it so that I can get a total solution of 100.0 milliliters. I want 100 milliliters, so I'm going to do 8.33 milliliters of my concentrated solution, and this is how much water I'm going to add. So to figure that out, I simply do 100.0 minus 8.33. Excuse me. All right, so whenever I do that, I'm going to get an answer of 91.67 is what I get from my calculator, but then significant figures, we haven't done this in a while, so when I add, I look at just my decimal places. So that means this is going to round to this place right there, so I need to add 91.7 milliliters of water. So I'm going to start with 8.33 milliliters of my concentrated solution from the last problem, and then I have to add 91.7 milliliters to get me the 100 milliliters of water that it asked for. So let's look at another example of a dilution problem. If I have 2.37 liters, so there's a volume of 2.37 liters of 18 molar sulfuric acid, so there's my molarity that goes along with that volume, 18.0 molar sulfuric acid. I need to dilute the acid, so I add 4.40 liters of water. So this is the volume of my solution, and so my next volume is going to be that volume, 2.37 plus 4.40, because I'm adding that volume of water to this concentrated solution. So that's going to give me 6.77 liters of total solution. So make sure you pay attention to the wording of the question. I need to dilute it, so I add 4.40 liters of water. I'm adding 4.4, so I have to actually add 4.4 to my original volume. And the question wants to know, what is the new molarity? What is its new concentration? So M1 V1 equals M2 V2. So if I want to find M2, I'm going to divide both sides by V2 so that they will cancel out. So those will disappear there. So now M1 times V1, well, M1 is 18.0, V1 is 2.37, and V2 is 6.77. So I simply plug in my numbers and then I solve, and that gives me M2 is 6.301. But again, three significant figures. So I need to keep my three significant figures. So my final molarity is simply 6.30 molar. So now with a little bit of practice of looking at the way the questions are worded and doing a little bit of algebra, you should be able to solve for all the different parts of a molarity calculation problem, remembering to convert when necessary to get moles and liters in your molarity, and then doing a dilution problem is just a simple inverse relationship equation. It's not very complicated. So with some practice, I know that you guys can be really good at this, so hopefully you jump on it and you're like, this is not super complicated, and you know what you're doing. Thanks for watching. Have a day.